start it again. So, if we are, okay, in the previous one, chapter 10, what we are doing? Remember what we did in chapter 10? We are looking at two different samples, completely different, independent samples. We are not looking at before-after thing. We are looking at them independently. Remember we did x1 square and x2 square. We are doing it separately. This one we are completely different. You see, this is the best way you will know in your exam which t-test you are going to utilize. The moment you read the question and you look at the information given to you, and as soon as you look at that you have been given this before-after thing, right away you know you are dealing with two sample t-test, but you are dealing with the t-test, but you are talking about related samples design, meaning the sample is related. It's the same sample, measurements are taken twice. So what are the calculations? So we will need these calculations. We will need a standard deviation. We need to calculate the standard deviation. We need to conduct the t-test, and we also need to find out the degrees of freedom. If you recall the previous one, when we are dealing with independent samples, what was the degrees of freedom for independent samples? Degrees of freedom was what? N1 plus N2 minus 2, right? Because we are dealing with two samples. Here, we are not dealing with two samples. We are dealing with two measurements on the same sample. That means one sample. So degrees of freedom in our situation is N minus 1, not this one. Are you guys with me so far? So we need to calculate these things. The formulas and everything, they are given on page number 142. So these are the things we need to calculate. We need to calculate variance. From the variance, we need to calculate standard deviation and standard error, and then whatever the t-test we are going to conduct. The t-test we are going to conduct, the formula is given to you at the bottom of page number 142. The formula we are actually, realistically speaking, the formula we are going to use for this t-test, this before-after design t-test, is this one, the very last one. Look at this page, the very last one at the bottom. And remember, this M stands for X bar, average. Because in the whole textbook, it's not using the thing X bar, it is writing as M. So, is M sub D divided by S, like the standard deviation of this MD. So what are the steps of doing these calculations? And just like the previous one, we also have an effect size. Remember, I think the large effect was what? 0.80 and above was large effect. So, and remember one thing, when you are, if I am giving you, if you look at the homework, when you are dealing with this kind of questions, and the first question is, are these groups significantly different in marital stress using alpha equal 0.01? So you start writing, going step by step. And when you are done calculating your t(10) and you found out that you have to reject the null hypothesis, then do you need to calculate the effect size or you don't? You're right. If you reject your null hypothesis, then you do not need to deal with the effect size. You deal with effect size only if you cannot reject H sub 0. Then only you calculate the effect size. The same thing here. So, these are the steps. If you look at these first page, right there, they are typed in bold. Again, we will be following these steps. Step 1, we have to write down the hypothesis. Now, when you are dealing with hypothesis, in the previous case, we are dealing with 2 samples, like your homework. You have group 1 and group 2, non-directional. So we were writing our alternate hypothesis. We were writing as what? What was the alternate hypothesis in our previous chapter? Non-directional, to tell. Yeah, of course, not equal to, but what was the sign we are using? We are dealing with 2 samples. So mu1 not equal to mu2, right? That was the previous chapter. Now here, we are not dealing with 2 populations, 2 samples, 1 sample. 1 sample, 2 measurements, x1, x2, and then the difference. So, in this case, our alternate hypothesis is we are dealing with 1 population, so we don't need to write mu1 or mu2, 1 population, but our main concern is this difference between before and after. So that's why our null hypothesis we will write, non-directional, will be mu d stands for the difference, not equal to 0. That means the alternate will be mu d equal to 0.